Hello. I'll be presenting my course project for the Managing Machine Learning Projects course. So the problem that I'm looking to solve with machine learning is that train operators follow a reactive approach to unexpected infrastructure and train failures. And this can lead to delays, reduced safety for the passengers and the staff, higher maintenance costs, and inefficient resource usage. The target users for this would be the engineers and technicians, um, because those are the folks who actually fix the unexpected failures, and also those that are in planning roles. Um, right now, the only planning that they do is scheduled maintenance, which is, kind of a reactive approach. And then strategic decision makers would be planners and dispatchers. So dispatchers would be the folks who would perhaps change the route of a train or the train itself if it has issues. So I'm proposing that machine learning be used to solve these problems by predicting failures before they occur. So this can reduce service disruptions and optimize maintenance resources. In terms of what success looks like, this would include reduced unplanned downtime and mechanical failures. Infrastructure and track maintenance would be enhanced. Inventory and resource management could be optimized because there's times when the shops are just, or engineers and technicians are just really busy, and there could be other times where they're kind of like idle time or not as busy. In terms of metrics targets for outcome, um, studies have shown that unplanned downtime can be reduced by 30 to 50%. Maintenance costs can be reduced by 10 to 40%. The on-time rate of trains reaching their destination can be reduced by 30%. System availability can be increased by up to 18%. Output metrics, we can look at the coefficient, determination of coefficients, R squared, that should be greater than 0.8. And the mean squared error for the remaining useful life should be greater than 7,100 miles on motors that are running 124,000 miles. There's three sets of factors that I'll cover or that I'm recommending be included in the machine learning model. Sensors is the first set. So as you can see, there's vibration data, temperature data, acoustic emissions, electrical data, fluid and pressure data. Um, there's a second set is historical and usage information. So this will include your failure logs for the train, usage history, and maintenance records. And then the third set are environmental information. So this would include outside temperature, humidity, weather patterns like snow and rain. The track geometry, is the train going around a curve or is it going straight? And also the operating load of the train. In terms of the solution concept of this machine learning model, it's the transition again from reactive to a proactive condition-based model. And this would be done by analyzing real-time data from Internet of Things sensors. It's important that we validate this concept by first validating the sensor infrastructure to make sure that it's capturing all the necessary data, and then capturing the offline performance metrics. And then finally running a proof of concept with a small fleet of trains. In terms of system design, this would include cloud and edge. Edge because we're capturing all this real-time data and the sensors. So these would be more like lightweight models for the real-time alerts. And then we would leverage the cloud to have more complex models so that it could do more of the heavy lifting on the complete analysis and in uploading models across the fleet. Learning would be online and offline. Online would, of course, be the live data from the sensors. Offline learning would be done on the historical maintenance logs. And then prediction would be online prediction because we want that to be real time. In terms of potential risks in production, there's latency because of the sheer volume of input data. There could also be latency in the data pipeline or the model. There's also a risk for training server skew because there could be a discrepancy in the sensor data between sensor data that's used in the training versus the one that's used in production. And then also there could be UTC versus local time um, discrepancies as well. In terms of data drift, we have to watch out for that as well as a risk because as sensors age, they may become less sensitive or give inaccurate information. And then also weather conditions could cause data to drift as well. Concept drift. So there could be changes in train schedules or changes in the routes themselves. So thank you for your time in reviewing this presentation and hope you have a good rest of the day.